What if the country best known for pasta, passion, and precision cars was quietly building one of Europe's most technically advanced militaries? What if Italy, long dismissed as NATO's charming southern outpost, more famous for its art than its artillery, had turned its flair for design into an arsenal of innovation? Beneath the marble calm of Rome and the sapphire waters of Toronto, something extraordinary is stirring. In hidden hangars and coastal shipyards, a quiet revolution is taking place, one powered not by bluster, but by brilliance. The same precision that once built V12 engines now fine-tunes hypersonic guidance fins. The craftsmanship that once created world-class yachts now forges frigates capable of hunting submarines across hemispheres. Italy is preparing. Its generals no longer think in terms of borders, but bandwidths, satellites, and swarm intelligence. Its shipbuilders talk not about displacement, but data fusion. Engineers from Turin to Genoa are merging aesthetics with lethality, producing machines that are not just deadly, but beautifully deadly. And while the world's attention drifts elsewhere, to the Arctic maneuvers of Russia or the industrial might of Germany, Italy is quietly constructing a defense network that might redefine how Europe fights its wars. A blend of artistry and algorithm, craftsmanship and combat, the Renaissance reborn, this time in steel, silicon, and stealth. This is not the Italy of the past. This is Italy 2.0, a nation where design meets deterrence and beauty hides behind ballistic glass. Because the next great European power may not march from the north, it may rise from the Mediterranean. So how does a country known for culture and cuisine become a silent superpower in technology and defense? Could Italy's fusion of design and defense be the blueprint for the future of modern militaries everywhere? Welcome to the new Italy, where design meets destruction and beauty becomes ballistic. Italy has always worn elegance as armor. From the arches of Florence to the canals of Venice, its beauty has masked its power. But beneath the Renaissance charm lies a defense industry evolving in deliberate silence, one that's quietly reshaping the balance of European military capability. While the world's headlines in the early 2000s celebrated Germany's Leopard tanks and France's Rafale jets, Italy was following a different path. Not mass production, not flashy numbers, but precision, innovation, and cunning. Its approach is less about intimidation and more about outthinking any adversary. At the center of this transformation are names most associated with luxury and engineering excellence: Leonardo, Fincantieri, and Iveco. These companies didn't simply pivot from civilian to military production. They leveraged centuries of Italian craftsmanship, applying it to defense in ways few expected. Supercars became templates for armored vehicle engineering. Yacht hulls inspired stealth ship designs. Advanced avionics evolved from race car telemetry systems. Precision wasn't just a goal, it was a mindset. But the real change began far from the public eye. In La Spezia, shipyards that once built cruise liners began assembling frigates and submarines with modular, network designs. In Rome, radar labs developed systems capable of tracking multiple targets at once, integrating satellite feeds and AI-assisted prediction algorithms. Near Turin, digital training centers blended virtual reality with live exercises, creating a generation of soldiers fluent in cyber and conventional warfare alike. Italy's ambition was clear: build weapons that don't just perform, weapons that anticipate. Unlike nations chasing sheer scale, Italy bet on smart warfare. Its strategy relies on asymmetric advantages: advanced electronic warfare suites that can blind enemy sensors, modular naval platforms that can be upgraded mid-life lightweight armored vehicles that carry the punch of much heavier machines. Every project reflects the same philosophy: minimal footprint, maximum impact. Yet, perhaps, the most astonishing example of this new mindset is the development of radar and surveillance technology. Italian engineers are now producing systems capable of detecting threats at ranges once thought impossible. These radars aren't just passive eyes in the sky, they can track drones, aircraft, and missiles simultaneously while feeding real-time data to command centers. It's a fusion of hardware and software, of craftsmanship and computation, designed to see the battlefield before the enemy even enters it. If you're enjoying this deep dive, please like the video and consider subscribing to our channel. Your support helps us bring more global insights. Now, back to the video. And while Italy has stayed quiet on its military ambitions, the results speak for themselves. Modern frigates slip through the Mediterranean with stealth coatings and precision weaponry. Armored vehicles combine speed with survivability, and cyber units quietly monitor networks across continents. The nation that once built Ferrari engines now builds the tools that could define Europe's next war. And at the heart of this silent rearmament lies a single truth. When Italy builds, it builds to astonish. The proof begins with a radar so advanced it can see the future. Still, can a radar system change the entire game of naval warfare? Meet the Leonardo Kronos Dual Band Radar, DBR, the brain, the heartbeat, and perhaps the most secretive jewel of Italy's next-generation defense. While most nations split their radar capabilities into separate systems, one for long-range detection, another for precision tracking, Italy asked a bolder question: why not do both at the same time? The Kronos DBR fuses C-band and X-band ISA radars into a single integrated array. The C-band Kronos Quad provides broad, long-range surveillance, detecting incoming aircraft, ballistic missiles, and even stealthy platforms from hundreds of kilometers away. Meanwhile, the X-band Kronos Starfire hones in with surgical precision, tracking fast-moving drones, small boats, and precision-guided munitions at sea level, even if they're as small as a seagull. Together, the two systems form a 360-degree digital eye that never sleeps. The real genius, however, isn't just detection, it's fusion and AI-assisted decision-making. The FREMM EVO frigates, Italy's latest naval masterpieces, will harness this radar with AI-enhanced systems capable of orchestrating multiple defensive layers simultaneously. Counter-UAS operations, electronic warfare, and gunfire support are all coordinated seamlessly across platforms. In real time, the system can detect a threat, evaluate its trajectory, prioritize responses, and launch intercepts faster than any human command could react. Picture this: a swarm of drones approaches from multiple angles. Missiles streak over the horizon. Conventional radar might catch some, miss others, but Kronos doesn't just track. It predicts, calculates, and alerts operators before the first missile reaches firing distance. In effect, Italy is giving its Navy the ability to see the battlefield before the enemy even enters it. By 2027, these ships will operate as fully integrated semi-autonomous defensive hubs, the ultimate combination of Italian craftsmanship and computational power. But what happens when the target doesn't just hide, it dodges? When a missile moves at hypersonic speeds, weaving unpredictably through the sky, conventional interceptors fail. Italy answered with a weapon that doesn't just follow the rules of physics, it bends them. A missile capable of outsmarting its prey, guided by eyes that never blink. If radars are the eye, then the Aster family is the reflex, the weapon that doesn't just follow a target, it anticipates and corrects in the last heartbeat. Italy's Aster 15 and Aster 30 are already household names among defense specialists, but their deadliest secret is one word: PIF-PAF. So what exactly is PIF-PAF? It is a hybrid control concept whose name comes from French, pilotage on force, and it is exactly as dramatic as it sounds. Instead of relying only on aerodynamic surfaces to steer in the terminal phase, the Aster couples those surfaces with a set of miniature lateral thrusters mounted at or near the missile's center of gravity. In short, aerodynamic control, PAF plus direct thrust control, PIF. The combination gives the missile two distinct ways to change direction, and they work together, instantly. It's because aerodynamic control alone eventually hits limits. At very high angles, thin air, or the extreme lateral accelerations needed to catch a maneuvering target, control surfaces can lose authority or overstress the missile airframe. The lateral thrusters bypass those limits. They apply instantaneous side forces close to the CG, so the missile can pivot without the twisting and bending that would break a conventional body. Maneuvers measured in tens of G, commonly cited up to 60 G for the Aster family, and terminal speeds approaching Mach 4 to 4.5. That combination turns the Aster's terminal DART into a reflexive, hyper-agile interceptor. The Aster uses a lightweight, highly maneuverable terminal, DART, that carries an active RF seeker and an inertial guidance package. Early phases of flight use INS and mid-course updates. In the final seconds, the active seeker locks on, and the PIF-PAF system gives the DART near instantaneous steering. The missile doesn't simply chase the target's last known position. Its guidance logic computes predictive intercept vectors, correcting for evasive maneuvers in real time and applying PIF bursts to pivot the DART into the kill zone. That's how an interceptor can outthink a maneuvering warhead, rather than merely pursuing it. So how does this pair with Italy's sensors in C2? A hyper-agile missile is only as good as the data that cues it. That's why systems like the Kronos DBR and the broader PALMS or SAMP-T architectures matter. They supply fuse tracks, trajectory predictions, and cooperative engagement cues across ships and land units. In practice, that means one ship's radar can hand off a track to another ship's missile, or an AI fuse solution can predict the target's likely evasive arc and preload intercept solutions into Aster's fire control, giving the dart a head start in a microsecond battle. The interplay of Kronos-like sensing and Eurosum missile brains is what converts Italian engineering into real operational advantage. But Aster is not purely Italian. It's the fruit of a Franco-Italian industrial partnership. But Italy's industrial culture and systems integration skills have been central to turning the concept into fielded capability. The Aster's success at intercepting conventional cruise and ballistic targets and the recent orders and production surges show Europe doubling down on the design. In 2025, several European navies placed fresh orders to replenish and expand stocks, a sign that the missile's performance continues to be trusted in live operations. Imagine a hostile anti-ship missile arcing in at extreme speed and low altitude. Kronos sensors lock it early and begin sending refined tracks. Fire control computes a bank of intercept solutions and launches an Aster. When that incoming missile suddenly breaks to evade, the Aster isn't surprised. It fires a PIF burst, pivots around the CG, and the dart's fins refine the final attitude for a calculated, kinetic, or proximity kill. The whole sequence measures in seconds, or less. But defense isn't only about how you strike, it's how and when you choose to reveal yourself. A system that can see and outmaneuver a threat still needs to control when the world notices a response. That's where launch signature matters. The smoke, heat, and noise of a missile launch are detectable by satellites, coastal radars, and even adversary watch lists. If you can reduce that launch signature, or eject a missile in a way that produces minimal plume and acoustic signature, you gain the advantage of surprise. What if your enemy's air defense never even knew you fired? Italy's answer is equal parts engineering and theater craft. The CAMM-ER, the extended range member of the Common Anti-Air Modular Missile family, built to vanish before it arrives. It isn't just another surface-to-air missile. It's a system designed around concealment, surprise, and networked lethality. At the heart of the ghost trick is soft vertical launch, SVL. Instead of firing its rocket motor inside the launcher, CAMM-ER is ejected gently from its canister by a gas generator. Once clear of the ship or launcher, the missile uses lateral actuators to roll and point toward the threat, then lights its motor and accelerates on course. Because the rocket doesn't fire in the cell, there's far less thermal and acoustic spill on the platform and far less immediate infrared and radar signature for distant sensors to detect. The result? A launch that looks, from afar, like nothing at all. CAMM family missiles are designed to live sealed inside canisters for the length of their service life, reported as roughly 10 to 20 years, which removes the logjam of periodic maintenance and handling that creates both logistic risk and visibility. A sealed canister means fewer maintenance windows, fewer dockyard signatures, and a stockpile that can be quietly left in place, ready but invisible. That set it and forget it profile is as much about operational security as it is about cost and readiness. CAMM-ER carries an active radar seeker and communicates via a two-way data link with its launcher and wider sensor networks. That two-way link lets the missile receive target updates and retasking commands after launch, and it can also send back status or health telemetry. Through this link, a dispersed sensor, likely a shipboard radar, shore battery, or airborne platform, can cue the missile and provide the high-fidelity tracking needed for accurate engagement, all while the launch signature remains vanishingly small. That networking capability turns each CAMM-ER into an arrow in a distributed quiver rather than a lone shooter. Imagine a coastal battery hidden in olive groves, a small corvette patrolling the littoral, or a land module parked in a suburban garage. Each hosts CAMM-ER cells that give 360-degree protection, yet reveal nothing when they shoot. In practice, a radar on a larger ship or an AWACS queue will hand an incoming threat to the nearest CAMM-ER battery. That battery ejects a missile quietly, the missile ignites out of sight, and the engagement is already underway. Before an adversary's watch, officers finish taking notes. That is how Italy converts technical stealth into tactical surprise. But no system is magic. Soft launches reduce signature, but don't make launches invisible. Hyperspectral IR satellites, very close coastal radars, or human observers can still detect activity under certain conditions. Networking and data links are force multipliers but introduce dependencies. Degrade the network and you reduce advantage. CAMM-ER's design addresses many of these risks, but commanders must still manage sensors, emission control, and tactical sighting to exploit the missile's strengths. If CAMM-ER is the silent hand that pulls targets from the dark, Italy's ground forces supply the predators that move inside the kill zone. Now we have a beast on wheels, a design that blends speed, armor, and fire control into a single lethal package, the Centauro. The Centauro series answers with an emphatic yes. The B1 and B2 variants combine high-velocity mobility with fire control sophistication. The B1's 105mm with 52 caliber stabilized gun uses the term's fire control suite, the same core that guides Ariete MBTs. With thermal imaging, laser range finding, and a digital ballistic computer with muzzle referencing, Centauro platforms execute hunter-killer sequences in under a minute, often while moving. The B2 variant increases protection and survivability, enhanced composite armor, improved mine and IED resistance, and a powertrain delivering 20.8 horsepower per ton from a 520 horsepower Iveco engine. And the result? A wheeled tank destroyer that can sprint across terrain, deliver precision fires, and relocate before enemy counterfire can be coordinated. In expeditionary windows or rapid reaction theaters, Centauro is a predator built to dominate mobility corridors. But how do you give pilots years of combat in a single sortie? Leonardo's M346 Master is a trainer with teeth. Achieving transonic speeds without afterburner and controlled by a quadruplex fly-by-wire system, the M346 delivers a realistic, high-performance flight envelope. But its real marvel is the Embedded Tactical Training System, ETTS, enabling live virtual constructive training. One aircraft can emulate sensors and weapons, interact with simulators on the ground, and create realistic, networked threat environments. For a nation that prizes precision, LVC shortens the learning curve dramatically. Pilots learn systems of systems combat, air-to-air, BVR engagements, and integrated strike packages, in a fraction of real-world sorties. The M346 transforms training time into combat readiness, an unsentimental efficiency that pays dividends the first time systems are stressed. Training and mobility matter, but so does sea control. Italy's naval guns and missiles make littoral denial brutal and precise. What happens when rapid-fire naval guns meet guided long-range shells and AES-enabled anti-ship missiles? The Otto 76-62 Super Rapid isn't a relic. At 120 rounds per minute with selectable firing modes and the capability to field volcano-guided munitions, 40-kilometer range, and Dart RF-guided projectiles, it's a precision tool for modern littoral conflict. With reaction times under 3 seconds and SD below 0.3 millirads, it converts rapid fire into surgical strikes. Complementing gunfire is the Teseo Mk2E anti-ship missile. This missile's dual-mode homing head, coherent ASA RF seeker combined with electro-optical sensors, plus an ECCM suite and two-way data link, allows in-flight retargeting and mission reassignment. With a scalable warhead and high G terminal maneuverability, Teseo Mk2E is a multi-environment threat, from swarm interdiction to strike against high-value naval nodes. What if the military you underestimated yesterday suddenly made you rethink everything you thought you knew about power, precision, and survival? Italy's military isn't just modern, it's subversively clever. It doesn't announce itself with blaring sirens or parades. It whispers in ASA signals, maneuvers in Centauro wheels, and strikes with PIF-PAF guided fury. The Renaissance nation has applied the same obsessive artistry it uses in cars and fashion to the business of war. And the result is terrifyingly elegant. From Kronos' omniscient gaze to CAMM-ER's ghostly launches, from the underwater stealth of A244 torpedoes to Ariete tanks networked into the battlefield like digital synapses, Italy has built a military that thinks, adapts, and punishes with precision. It's not the biggest, the loudest, or the flashiest, but in a world where milliseconds matter, it could be the deadliest. The real mind-blower isn't a missile, radar, or tank. It's the integration, the seamless orchestration of cyber, land, sea, and air. A single misstep by an adversary could cascade into total defeat before they even realize it. That's not speculation. That's engineering. That's strategy. That's Italy's quiet revolution in war. So next time you picture Italy as vineyards, pasta, and stylish streets, remember this. Beneath the beauty, behind the sunlit coastlines lies a military you cannot see, but you absolutely do not want to test. And that is the ultimate mind blower. If you found this analysis valuable, please consider subscribing to our channel for more deep dives into geopolitics. We would love to hear your thoughts. Drop your comments below and let us know what you think. Thank you for watching, and see you in the next video.